Hello everyone, today I'm going to talk about quantum entanglement and the EPR paradox. So what is quantum entanglement? Consider we have two identical boxes, and each box is filled with either a hot dog or a burger. Now let's move these boxes away from each other. When I notice a burger in one box, instantly we know that other box has a hot dog in it. Now let's bring this concept to quantum mechanics. Consider two particles which are in superposition state that it can either be blue or red. After interaction between two particles, each particles are put into identical box and are sent to different place. One box is sent to Alpha Centauri with Alice and another is staying in Busan with Bob. As soon as Alice finds out the color of her particle to be red inside the box, the color of the particle in Bob's box is fixed as blue. At quantum scale, sometimes particles can become connected in a way that measuring the property of one particle affect the other instantaneously, no matter how far apart they are. This is the concept of quantum entanglement. However, Einstein was not very happy with this interpretation. If finding out the color of a particle in Alpha Centauri can affect the color of the particle in Busan, he believed that it would require any type of information transfer. But this cannot be faster than light according to special theory of relativity. He called this spooky action at a distance and claimed that quantum mechanics are not complete. Instead, he believed in hidden variable theory. This is another way of explaining quantum mechanical phenomena, just like Copenhagen interpretation. Instead of probabilistic explanation of the world, hidden variable theory believes that there are unobservable hypothetical entities underneath, which give rises to quantum mechanical phenomena. This concept attempts to deterministically describe quantum mechanics, avoid indeterminacy, and it is famous that Einstein declared, "I am not convinced God does not play dice." In 1935, Albert Einstein, Boris Podolsky, and Nathan Rosen published a paper challenging the Copenhagen interpretation. From their view of hidden variable theory, there were two main concepts. First one is reality, that microscopic objects have real property, determining the outcomes of quantum mechanical measurement. And second one is locality, that reality in one location is not influenced by measurements performed simultaneously at a distant location. From their first name, their opposition in paper is called the EPR paradox. So from the particle example, they were not in superposition which are entangled to one another, but at some time they were already determined to have specific color. However, since the consequences that the colors will be different is exactly the same when we open the box with both interpretation methods, it is really hard to be tested. In 1957, David Bohm published a paper supporting Einstein's view on EPR paradox by designing a new thought experiment using spin of an atom instead of position and momentum of particle as in the original paper. Imagine a particle with total spin 0. When they break apart, two electrons will have opposite spin because total angular momentum in the atom should always be conserved. This characteristic of electron according to its rotation is called spin. In 3D world, we can measure angular momentum of the spin according to x, y, and z axis. Because of their realistic property, they will have specific value no matter we measure it or not. However, in quantum mechanics, electrons are in superposition until they are measured. Also, when we measure one angular momentum over x-axis, the value of angular momentum of y and z-axis are not able to measure. David Bohm claimed that if we measured angular momentum along x-axis of electron A and along y-axis of electron B at the same time, we can find out both values along x and y axis at the same time because angular momentum is conserved. However, this seems to violate the Heisenberg's uncertainty principle. In 1964, John Stuart Bell published a paper on the side of the Einstein on the EPR paradox. He proposed an inequality which should be true if hidden variable theory is true, and an experiment to prove this. This is called the Bell's inequality. Here we have a detector to measure the spin state of an electron. When two detectors are parallel, there are 100% chance for two electrons to have opposite spin. We can multiply two values considering up spin as 1 and down spin as -1, getting -1 as its correlation. When two detectors are anti-parallel, there is 0% chance for two electrons to have opposite spin. So here we have correlation to be 1. And what happens if two detectors are put orthogonally? The odds of having opposite spin are 50%. So in this case, correlation is calculated to be 0. So we can calculate the correlation. This is the chance of having n. We can calculate in the same way, and we add this, we get the 0 correlation. And until here, these are the same for both quantum mechanics and classical mechanics. However, what happens when the angle of the detectors are set between 0 and 90 degrees? According to classical mechanics and Einstein's side of the debate, which are presented as red line in this graph, the correlation and the angle between detectors should have linear relationship. On the other hand, with mainstream interpretation which believed in quantum entanglement, it should follow the reverse cosine graph. This graph can only be true when real spin of a detector is in superposition state until measurement. And what was the result of the experiment? Surprisingly, it turned out that quantum mechanical explanation is true, and quantum entanglement really exists. So what we have seen is when the angle is 0, antiparallel, and 90 degrees. But between these angles here, we have different results from quantum mechanics and classical view. In the experiment, the result told us that the quantum mechanical interpretation is real. Then, does quantum entanglement really violate the relativity, so there's spooky action at a distance? Odd as it might seem, they still doesn't violate relativity, since the only thing in exchange is the internal quantum state. No external information is really passed. Hard to understand, right? As Richard Feynman said, nobody understands quantum mechanics. This conclusion is still not easy to accept. Maybe because of this, there are still other attempts to explain this phenomena using other theories, such as many words interpretation. So this is the end of the video. Personally, it was really interesting for me that EPR paradox, which was proposed to disprove quantum mechanics, led development in quantum mechanics. Ironic, isn't it? Thank you for joining for my video. Please have a nice day.